Hey guys, in this lesson we're going to look at some quadratic inequalities and solve those. So thanks for watching. Don't forget to like, comment, and subscribe. Inequalities and quadratics. We solve these pretty much the same way we do with equations. However, these answers will usually be in intervals. When we do that, we're going to split the number line up into sections based on the values that give us equality. And then we got to test each interval to see if it gives us a true or false statement. If one value in that interval gives us a true statement, then the rest of them will as well, assuming that we've solved it correctly. Like this one, okay? So we need to break this up. And also we kind of want to treat this as though we're an equality. So we're going to just rewrite this as x squared minus 2x minus 8. But now it equals 0, okay? So we're treating it exactly like an equation. And if we can solve for the values where we have equality, then we can test the other values on the number line, okay? So I need two values of negative 8, two factors of negative 8 that add up to negative 2. I'm going to use negative 4 and positive 2, which means that I really have x plus 4. And also, wait, no, it's not plus 4, it would be minus 4, sorry. X minus 4 and then x plus 2, and this would equal 0. And if we were to solve that, right, then we could say, well, if x minus 4 equals 0, that would be true. So x would be 4. But if we could get x plus 2 to equal 0, that would be true as well. So x is also negative 2. So this is where we have equality in the equation. Well, for the inequality, though, we're going to need to look at this on a number line. Now, it's not too bad to graph this. We got the negative 2 and the 4. And we got to test these intervals. On this number line, there's 3 intervals. We have, let me put that down here. What I mean by that is we're separating this at negative 2 and 4. Everything to the left of negative 2 is its own interval. Everything between negative 2 and 4 is its own interval. And everything to the right of 4 is its own interval as well. Now, since this was just in the beginning, right, x squared minus 2x minus 8, that was just greater than 0. So it's going to be open circles, one way or the other. But at negative 2 and 4, okay? Now going back to what we were talking about earlier, we got to test each of these intervals to determine which of these is true and which of these is false. All right? Which means we can't use negative 2 and 4 because that's where we get equality. All right? So I need any value to the left of negative 2 to test in the original inequality. So we are going to test negative 4 and just see if that gives us a true statement in the original expression. So we've got x squared, so negative 4 squared, minus 2 times negative 4, minus 8. And the question is that greater than 0? Yes. Yeah, right? What? 16 is greater than 0? So that is true, which means that everything to the left of negative 2, but not including negative 2, it would also give us a true statement on that, okay? Which means it's part of the actual interval that we will include as part of our answer, all right? Well, let's test the next value. I need a value in between negative 2 and 4. Sorry, I'm going to use 0 because it's so easy to use. So now I've got, for this one, I've got 0 squared minus 2 times 0 minus 8, and this needs to be greater than 0. Well, evaluating this, I get negative 8 is greater than 0, which is false. So this interval or section is false, which means it will not be included in our answer. Next thing we need to do is test from 4 to the right, and I just need any good value. 5. Bam. There's 5 right there. So this would be 5 squared minus 2 times 5 minus 8. And is this greater than 0? Yeah, we get 25 minus 10, 15 minus 8, 7. 7 is greater than 0, so that is true. So that means we're going to be including, write true over here, everything to the right of 4. Now going back to what we know about the intervals, hopefully the number line helps us to write that out. So we have the green interval, which goes all the way to negative infinity, but then it stops at negative 2, and again, since it had no equal part to it, it's just not included right there. It does skip it, so we are going to unite this with the blue interval starting at 4, which also was not included. And if we went all the way to the right, it would go to infinity. Done. All right, this one does have a coefficient for x squared, or it has an a value other than 1. So we need to multiply the a and c. 10 times negative 2 is negative 20. And I need two factors of negative 20 that add up to positive 1. Looks like I'm going to be using positive 5 and negative 4. Now since we got the 10x squared, we need to split that 1x up into those two factors, 5x and also negative 4x. And we're going to make this equal to 0. We're not so concerned about that greater than or equal to part yet, right? Not until we get to the testing portion. Well, this brings us to factoring by grouping. So I'm going to factor out from the 10x squared plus 5x. I'm going to factor out a 5x. So I've got a 2x plus 1. And from the second 2, right, I'm going to factor out a negative 2, which leaves me with 2x plus 1. And if I continue to factor that, I could factor out a 2x plus 1 from both terms, which would leave me with the 5x minus 2. And yeah, that does equal 0. So this means that if I can make 2x plus 1 equal 0, that would be true. And skipping a few steps, we get x equals negative 1/2. And the other one, 5x minus 2, if we could get that to equal 0, that would give us a true statement. And again, skipping a few steps, we get x is 2/5. So on our number line, let's consider negative 1/2 and also positive 2/5. Now again, we're breaking this up into the 3 intervals or sections like this, right? And I need any value to the left of negative 1/2 to test in the original equation.
Why can't we use 1/2? It's included.
All right, let's test starting with negative 1, about right there. So I've got 10x squared, so that's negative 1 squared, plus 1 times negative 1, our testing value, minus 2. And does this equal, that's a question mark, is that greater than or equal to 0? Negative 1 squared is 1, so I got 10 plus 1 times negative 1, that's negative 1 minus 2. This is greater than 0, so it's 7 is greater than 0. That is true. So we know that everything to the left of negative 1/2 is true. Some of you can kind of guess what's going to happen with the next part. I'm going to test, 0, because it's between negative 1/2 and 2/5. And that would give us 10 times 0 squared plus 1 times 0 minus 2, and again it's a question mark, is that greater than or equal to 0? Well, it gives us negative 2 is greater than or equal to 0, which is false. All right, now we're going to go to the right of 2/5 and test any value to the right of 2/5. All right, using positive 1, yeah, okay. So 1 would be somewhere over here. So I've got 10 times 1 squared plus 1 times 1 minus 2. Is this greater than or equal to 0? So 10 plus 1 minus 2, 9, is greater than or equal to 0. That is true. So we know everything to the right then of 2/5 also is true. And this should help us to create our interval notation. So So once again, I'm going to start with the purple interval just because it's farthest to the left there. And that goes all the way to negative infinity and stops at negative 1/2. Now this one also had the equal portion on that, so it's included in the solution set. And then it skips, so I have to unite this, starting at 2/5, which also is included. And that goes all the way to the right to infinity. Solve and write the answer in interval notation. Now we've seen a lot of factoring, all right, and we don't really like it. I don't know what we like at this point. But in any case, I'm going to change it up a little bit. And, well, let's rewrite this first, all right, as an equality, so we know where the intervals start and end. Now, some of you would look at this and go right into factoring, which is okay, you can. However, there is another option, and we could have used it on the other two as well, is the quadratic formula, all right? So I'm going to take negative b plus or minus the determinant b squared minus 4ac and divide it by 2a. This will also give me the values of the equality where this is equal to 0. 4x, right? That equals x. So my b value is that negative 19, which I can replace now. My a value is 15. And the c value is 6. All right, and we could just evaluate this, right? The negative of negative 19 is positive 19. That's pretty nice. Plus or minus is square root. Well, the square root of 1 is 1, so we really got 19 plus or minus 1 all over 30. And yeah, once again, we can make that two separate parts that we can solve. And 19 plus 1 over 30 would be 20/30ths. So that just simplifies to 2/3. And 19 minus 1 is 18 over 30. Just simplifying that, we would get 3/5. All right, here's our number line. We'll go to 2/3 and also 3/5. They're actually closer than this, I suppose, but we can exaggerate it. All right, looking to the left of this, I'm going to be using a value to the left. I'm going to choose 0 on that, which would give us 6 is greater than or equal to 0, less than or equal to 0. That's false. So we know that everything to the left of 2/3 is not true. What about between 2/3 and 3/5? Well, 2/3, that would be 10/15, and 3/5 would be 9. I apologize. It's backwards right there. All right. To test something between that, we need probably a new denominator. All right. 19/30ths. So evaluating that gave me some, negative value on that, which is automatically going to be less than or equal to 0. So that's true. So at least we have this interval between these two values, which is true. All right. What about to the right of 2/3? So we can choose another nice value right there. Let's choose 1. So then I got 15 times 1 squared, which is 15, minus 19 times 1, plus 6. And this needs to be less than or equal to 0. It's a 0. Well, what does that give us? Negative 4, 2 is less than or equal to 0. That's false. So another interval that would not work. All that stuff. Well, now let's write the interval. Okay, well, this is sandwiched, this interval sandwiched between 3/5. And yeah, that's a square bracket because it was included. And it goes all the way to 2/3, which also is included. There it is. X squared minus 5x plus 4 is less than 0. All right, let's factor out that 4, because you guys like to factor and stuff, right? You could use the quadratic equation on this. I'm going to use negative 4 and negative 1, which would add up to the negative 5. And this one is nice because we can break this one up directly to be the x minus 4 and also 4 and x minus 1. Now again, we're looking at this as an equation though, right? So if x minus 4 equals 0, that would be true. So that's where x is 4. But if we can get x minus 1 to equal 0, that would be true as well. So x is 1. Now for the number line, we have x is 1, but also x is 4. And I want to test the interval to the left of 1. So I'm going to choose 0 because that's always a nice value to use. Then I get 4 is less than 0, which is false. Now I need a value between 1 and 4. Let's test 2. Well, that would be 2 squared, which is 4, minus 5 times 2, which is 10. Plus 4, is this less than 0? Yep, that's negative 2. Is less than 0, so that's true. When we tested 2, so again, at least we know that this interval is going to give us truth. Next up, we'll test some value to the right of 4. We'll just say 5. Then I've got 5 squared, which is 25, minus 5 times 5, which is 25, plus 4 is less than 0. We got 4 is less than 0. That is false. Well, then we should be ready to write our interval. Well, here's our interval. I'm going to 1, and then it stops at 4. And, oh, this is, I used the wrong, wrong brackets. This is actually parentheses, because they're not included. We did it.